All right, so we're going to be tackling School Interface 1. This is the first of 4 challenges in the School Interface series. Oops, I don't want to copy, I want to fork this time, so I forgot last time. I'm going to fork this over to my personal repository. Let that do its thing. Should be done now. There we go.
Hey, Ankur, I have a question about the fork.
Sure.
Okay, so when you clone something, you copy it. What are you doing when you're forking something?
When you're forking something, I can imagine that as you're creating a branch from the main repository. So like if Platoon is your main repository, you're basically branching it and making changes. And then when you submit a pull request, that's you're attempting to merge back to the main repository.
That's perfect. Thank you. I didn't understand it.
Okay, so I'm going to clone down OOP School Interface 1. Then I'm going to cd into School Interface 1 and bring up the coding window. All right, so here's my VS Code. I'm going to make it larger, move it to a new window, and then let's get started. All right, so School Interface 1, what do we need to do for this challenge? Well, let's look at the README. All right, for this challenge, we're building a simple school interface for a school that will keep track of student records. There are many ways to create the functionality we're looking for, yada, yada, yada. By then, we'll see a list of students. Again, this is going to be an iteration. We're not going to complete everything today, but it looks like we have a runner file. So this is, again, when we give you runner code, that's basically the driver of your application. You need to make sure that runner will be able to do what it's going to ask you to do. Notice the import statements in order to keep our code organized. Yep, we use modules. All right, release 0, create classes. So we're going to start by initializing our school with a name. We need to create a class like that. All right, so let's kind of follow their examples. So we have school here. There's nothing here except the pass statement. Our runner has Richmond High. That looks cool. Data, we have our CSV files that we're going to read in. Okay, cool. So let's implement our school class. I know we have code we can copy, but I'm just going to practice typing here. So we need to create an init method. Again, this is a method. I'm going to make this a little larger. This is a method that we create to handle initialization stuff. So usually this will do one of 2 things. One, it will take in parameters. So this will be name. Anything else we needed? Nope, just name. The second thing is you might, that is all that. The second thing is that you might do some additional initialization that's unrelated to any parameters being passed in. Okay, we have name, and we're going to create some other items. So we have students. That's going to be a list of students and self. We have staff that works at the school. We're going to keep track of that. All right, so that's our really simplified school class that we created there. Let's take a look here. All right, so students and staff. Now we need to create student staff classes. So let's do that. For this, I'm just going to copy it because again, I don't want to make a mistake and I don't want to type too much either. So we're going to create a new file, call it students.py. Again, usually your names will be singular. So student.py, not students.py. So do that. I'm going to paste in that code. Now let's kind of just review it, make sure we understand it. So we have class student. Notice there's no inheritance here because there's no parentheses with something in there, right? I want to inherit, add something there. I could have empty parentheses here. That's totally fine. This just means there's no inheritance, but usually I prefer not having the parentheses there. Then we have our init method. Takes in self. Again, always remember that self as a first parameter. It can be named whatever you want it to be, but self is the coding standard or the agreed upon style naming convention for that. That's what I was looking for. Then we have a few parameters that we're going to pass in: name, age, role, school ID, and password. I think this was sort of confusing for maybe some of us. I think this should be student ID, even though we have school ID. I'm going to change it because, hey, we have liberty to kind of control what we want. So as I talked about, just because we give you code, if you think it's incorrect, update it. Do what you think is right for your solution. Don't always just assume we know exactly what is the best thing. So I'm going to call it student ID because that also matches the name here. Cool. So student ID. I think if I do that, I probably should rename this. So again, usually you shouldn't modify the data, but I'm going to take the liberty here. So student ID, I'll call that there. All right, nothing too exciting going on in this init method. We're just creating instance variables and then assigning to them. So that seems like our student class. And we also need a staff class. So I'm going to copy that, create a new file. Let's call that staff.py. Make sure it's outside. All right, staff. I'm just going to paste in the code from our curriculum just to kind of expedite the process. But again, pretty simple class here. Class staff, no inheritance, and it takes in self, name, age, role, employee ID, and password. Okay, that looks simple enough. We have this, ignore this, but actually let's not ignore it. I think we learned about inheritance earlier this week, so let's actually try to use it. So let me figure out how to uncomment that. So let me see it.
Missed one of the things, so it's still crossed out.
Man, I could never get anything by this. Take that. Okay, cool. Thank you. And again, I'm just creating this on my local repository. We'll probably update it for future cohorts. But all right, we're down to ignore this portion. I probably should do that. All right, there's a lot of repeated code. So yeah, if we're looking at our two classes here, there's a lot of similarities here, right? Name, age, role, and password. All four of these fields are the same. Someone else mentioned this also. Effectively, ID can be shared also. Like you can have a generic ID. So, school ID, employee ID, both those are going to be integers. Both of them, again, based on the role, you can know who you're dealing with. But in our case, I think school ID and employee ID, we're going to keep them separate. But let's actually make this a little more, interesting. So what if I think Omar actually suggested this. So let's go with his suggestion. Set a GPA. Let's say students have a GPA that we keep track of. GPA is going to be GPA. So it's going to change my data a little bit. I'll pass in the GPA, and then my data is going to change. Again, we don't expect you to be doing such modifications. I'm just doing this to make this a little more interesting. So let's say Lisa is doing really well. Let's say she has 3.7. Let's say Jessie, she's really smart. Again, if you watch Save the Bells, she probably has a 4.0. Slater, he's not the most academically talented, so he might have like a 2.6 GPA. Say Kim, Kim's not a real, these aren't Save the Bells students, but let's say Kim is doing mediocre. I got a 3.1. Dave, let's say Dave's just not getting it. Let's say he's on that cusp. He's got a solid 2.0. Doug, I don't know. Let's say Doug has a 3.5. All right, so there we go. Save that, and good. We should have GPAs that we read in. All right, so let's look at what this is suggesting. So as our program develops, we want to discover the differences. Let's say I forgot those squigglies. So it's a good idea to keep these in separate classes, but we do want to keep our code as dry as possible. So we've talked about dry, a couple times. Dry stands for don't repeat yourself. The opposite of it is wet code. There's a few, what's it called? Terminologies for wet. One is we enjoy typing, which is kind of just saying, hey, you're probably writing duplicate code, so you're going to be typing more. I think wet can also stand for write everything twice, because again, you're just kind of duplicating code. Again, just kind of fun wordplay there. But again, keep your code dry. You don't want your code to be moist or soggy. You want it to be dry. This is where we use inheritance. So let's create a person class that's going to kind of aggregate the similar features of student and staff. Right? Again, if we talk about inheritance, person is a generic concept versus student and staff are more specialized idea of a person, right? If they're a person with additional features or additional capabilities. So that's why person is going to be our base class, and then we make it more specialized with derived classes. So to achieve this, I'm going to create a new file called person.py, and this is going to be our base class. So we're going to create class person, and then we're going to create an init method. Init, and always taking self. Then I think we have name. What else do we have? Password, role, and what was that one more? My memory is not the greatest.
Age.
Age. Thank you. Hey, realistically, we should probably take in birth date because age is not going to be consistent. Birth date, well, as compute age, but we'll go with age now because that's what they give us. And then just to save myself some time, I'm going to copy all this. So name, age, role, password. Looks like I got out of order, but that shouldn't be a problem. Name, password. Again, the order here doesn't matter, but for consistency, I usually will kind of align the parameters. Just that's what I do. You don't have to, so that they kind of go in the same order here. And okay, so we create our person class, and again, the intention of this is to be a base class for both staff and student. So let's update our staff class. Now we want to use inheritance. So this is going to inherit from the person class that we just created. But again, in order for Python to know what this is, we need to import that module. So in this case, I'm going to do an import person. Let's do actually from person import person. All right. Usually when I'm creating classes, I name this uppercase. Looks like I did not follow that this time, but person is basically the name of the file. So person.py. That's why this is lowercase p, because my file is lowercase p. But capital P person is referring to the actual class in that module. All right, so lowercase p person is my module, uppercase P is my actual class. Now keep in mind, you can use imports for functions also. So if I had a function here, like do something, I can import this function if I wanted to also. So with my import statement, again, kind of getting off track here, but if I wanted to use that function in this file, I could import do something just like I would import a class or a variable. So now I have access to that do something function from this module. Okay, but in this case, I don't really want that function. So let's get rid of it. Okay, so since I'm inheriting now, I don't need to keep track of this information in this box. So this is an example I brought up yesterday. I'm going to kind of reiterate it because it makes sense for me. Again, I'm a visual person. Imagine that staff is just like a box, and then you're putting items into that box. So right now I'm going to put name, age, role, employee ID, and password into the staff box. So imagine just like a cardboard box. You're throwing some items in there, but now we introduce a smaller box that we're going to place within the larger staff box. So this person is going to be a smaller box that we now add to the staff box. So what we're saying is we're going to take a few of those items that we put into the staff box and actually put them into the person box instead. The person box is going to be the item that's actually managing or holding on to that data. So in this case, person, that box, if you stay with my imagination here, is holding on to these items: name, password, role, and age. So we still need to pass in all of those items to our staff class or put into our staff box, but these can be further passed down to our person box. What is that magic method in Python that lets us automatically channel our parents? Does anyone remember?
Super.
Super duper. So super method, again, this method will automatically look up in the MRO and find the appropriate base class that's kind of next in line. In this case, we only have one base class, which is person. So super, again, doesn't have to really do much work. Like we know it's gonna be person. We could write person here, but as we talked about, so let me write this in here and then talk about it. So I could do init and then name, age. Oops, looks like my password. Notice my tooltip is telling me what order I need to go in. But what if I don't know the order of my call? Does anyone maybe know a way I can kind of add in parameters but have it still work?
Would this be a case where you could use that dictionary key thing?
Yeah, so we're not going to use a dictionary here, but we can use keyword arguments required. So again, if you kind of notice what I did here, my ordering, there's name, password, role, and age, which is not the same order as this. I have name, age, role, and password then. That was either intentional or unintentional. Regardless, if I don't want to keep track of the order, let's say there's like 50 parameters here and it's kind of hard to keep track of 50 ordered items. This is where keyword arguments become beneficial. So if I just know what I need to match up, I can do name equals name, age equals age, role equals role, which seems kind of silly. Like I'm just matching the same thing to the same thing. But this again allows me to get out of order with the receiver of these parameters. If I could find how to type password. Again, so these are keyword arguments, also known as quarks. So this lets me just say, hey, age, whatever parameter age is, accepts age from here as the value. So again, if I go back to my person class, I probably should have split screen. The order of this no longer matters now that I'm using quarks. The only thing that matters is that I give a value to each one of these arguments. So I need to still give a value for name, password, role, and age, but whatever order I supplied in doesn't matter now that I'm using quarks. So I still have name, age, role, and password. It's just they're out of order, but it doesn't matter now. All right, so that's one benefit of using quarks. You don't need to care about the order. Yep.
Question, would it be beneficial to use these quarks in your base class? That way it doesn't matter if when that base class goes into other classes. Would that
Are
make
you
more
talking
sense?
about adding like quarks here?
No, if you just did the exact same thing there, that way it wouldn't matter the order going forward.
I don't think you could do quarks on the receiving side.
Oh,
So
okay,
these are just
I didn't know that.
receivers, but they don't know like the name of the variables that are coming in, right?
got it. That makes sense.
So in here, they happen to be the same thing because the parameters were name, but if this were like name of someone, right, then this would have to be name of someone. Like there's no way for my person class to know what's coming in, like what variable is coming in.
That makes sense. Thank you.
Yep, no, thank you for asking that.
Ankur, can we
yeah.
use keyword args on like any function we're calling then?
Yep.
It's
In
okay,
fact,
cool.
you guys sort of used it yesterday without actually knowing you're using quarks. If you remember when Tom introduced, I need to go to a different page. When we introduced the dictionary reader, or was it just the plain reader in week 11 or week 2? Yesterday was the 14th. If you remember, where can I find it quickly? This mode, right? Remember, Tom was setting mode equals to whatever mode you wanted. This is an example of keyword arguments. So again, any function, yes, can support keyword arguments. So in this
Pretty
case,
handy. Thanks.
yeah, mode is probably some parameter like down the line, but if we don't want to specify those optional parameters, we can only pick which optional parameter we want to specify, and we do that with quarks. All right, yep, quarks are definitely handy, so get familiar with them if you're not yet familiar with them. All right, so we have our person class, we are passing these items down, so our staff box or our staff objects no longer needs to keep those items in its kind of like purview. It's passing that responsibility down to the person. But again, I chose to use person here, which is my base class. This will work, but again, this isn't the best design because again, hypothetically, what if we rename person to be like people? Or if we add another base class that takes precedence like stuff and then person. Again, I don't have the best examples here, but now stuff should get priority, but we've hard-coded person here, which might make sense. But again, usually we keep it dynamic by adding super here so that whatever the base class is, it's just going to call that. Again, if we explicitly need to call a particular base class, then that might be a use case for actually calling that base class directly rather than super. But for the most part, most of the time, just stick to using super unless you have a reason not to. Okay, so again, we're passing that data down, so we don't have to keep track of it here. Let's do the same for student. It's going to look very much the same, so much so that I'm just going to copy here, so I don't have to type all that again. So we have these 4 items that can be simply super inits, but we need to still import person and inherit from person here. So from person imports person. Okay, so notice that student ID and GPA, these are our responsibilities that we're giving to student, as in that student box is going to hold on to that data, but the person box is going to hold on to name, age, role, and password. Again, we could migrate ID down to our person class. Again, this is where your critical thinking, your designer mode. And again, someone brought this up where, what if we just had ID here and kept track of ID here, right? Regardless if it's the staff or student, they both have an ID, so why not centralize it here? That's totally legit thinking, and I would actually argue that's probably the way we want to do it. But I think, for example, just to kind of highlight the purpose of these classes, we are going to keep them separate. Again, not maybe the ideal design decision, but we're just going to go with it if you guys can play along here. All right, so I think we've set up inheritance here. Any questions about our base class, why we did this, or how it's working? Please ask if inheritance is still kind of a bit murky on your end. Okay, so I think we should have accomplished release 0. Let's actually test it out before we're obviously committing it. So let me bring up my terminal. We're going to run our runner file. So that's going to be python runner.py. We got rich on how, nothing too exciting right now, but that is what we expected. So where am I going here? Runner, there you are. Yep, so again, we're instantiate, again, get familiar with that terminology, instantiate a school instance from the school class, obviously, and then we're just printing out the name. So again, our school class has these 3 attributes. These are instance attributes. It has a name, and right now, empty list for students and staff. Okay, so we did the inheritance. Hopefully you guys were able to do that too. Refactor with dictionary and quarks. The code in our class is much cleaner now. Let's do some more refactor. Right now when we initialize, yes, this is kind of what we went over yesterday in stand down. But if we want to create students, or we could do it by passing in values, or create a dictionary and use the spread operator like we talked about. Okay, so again, we covered this yesterday, but we'll cover it again just to kind of highlight it. So if you create a dictionary, I'm going to do this in my runner file. Let's do from students, import student. All right, so again, just talking about quarks, let's create a dictionary that has student data in it. So I'm going to call that students info. That's going to be a dictionary, so curly braces, and then the info is going to be name, student ID. What else? We have age, role, and what was the last one? Password. Password. Okay, so now we're gonna add some values for particular students. Oops, all right, name. The name of our student is going to be Screech. Since he was left out from the initial challenge, let's add in Screech. Student ID will be 4680. Age, I don't know how old Screech was, but probably he was in high school, so obviously they covered all years high school. Let's say he's 17 in this particular example. Role is student, and password is does Screech have like a saying or a tagline or something? What was his robot saying? Anyone remember his robot saying? No hardcore to say about Panzer? All right, we'll just say his password is robots. Okay, so we have this dictionary. So again, this is something we'll eventually read in from our CSV file. So I think that's part of school interface 2, unless I missed something. Oh, okay, we'll get to that. But school interface 2, school interface 1, we're going to be reading in data, but eventually, or ideally, we want to read it in as a dictionary, and then we should be able to create a student instance. If I do something like students equals student, instead of passing in these values individually, I simply can break apart that dictionary. Excuse me, and that should let me kind of expedite that process. Again, the key thing here, and I said this yesterday, I want to highlight it, but for this to work, the names of your keys in your dictionary, and then by extension, the names of your headers, looks like I need GPA, names of your headers should match exactly. The naming does matter there. It's not, you don't have free range there if you want to use this approach here. So go back to my runner, we need to add GPA. Screech was definitely a smart kid. So let's say he had a 3.9. All right, so now again, the names of this should exactly match your student interface here. So name, age, role, this naming does matter. So now if I've done everything correctly, I should be able to leverage using the spread operator. So let's actually check that out by doing a, hopefully there's no error here, print student dot name. All right, any questions about using quarks? Again, pretty simple to use it. Just hopefully you understand why it's working. So Python runner, there we go. We get Screech. Looks like everything works. Great. All right, so I think that accomplishes release 0. And I don't think we had to do anything for release 1, actually. Trying to read this. Okay, I don't think release 1 actually has us do anything except for moving classes to the class folder, so let's do that much. Kind of doing 2 releases together. Well, let's create classes and move school. Oops. Apologies, on a folder called classes. And we'll move school, staff, students, and person into that folder. Again, this is for code organization. Again, as our projects get larger, you're gonna have more and more folders and hopefully organize your code appropriately. Now that I did that, I need to update my imports. So these classes. While I'm kind of updating my imports, any questions that crept up about what we've done or what any conceptual things that we want to talk about?
I had a question about, I guess, general structure. You are putting each individual class into an individual Python file there. I take it that's kind of convention, but I mean, these are really, really small files, and just for ease of use, it seemed like it would have made a lot of sense to just have staff person and student all in one file to kind of just be like, to keep the structure, but just have it all in one file to make it a little bit easier to get around and import stuff easier.
Gotcha. Yes, glad you asked that question. Typically, during lecture, we tend to combine classes just for ease of use, like basically seeing everything on one screen and one file. But with that said, yes, best practice and highly recommended. Even if it's super simple, small class like this, still create a new file for it. Get in that habit. Even though you might be like, this is kind of unnecessary, it's gonna, cause me to have some import headaches, do it. Because again, this is how you should be organizing it. Yes, even if you have 4 lines, 5 lines in one file, that's still the proper way to do things. Yep. So get in the habit of creating, multiple files for each class. Again, there can be exceptions. Like if we're gonna create maybe like a class smart student, I could see some reason for not creating a new file for my drive class here if it's just gonna be like a simple placeholder. But for most part, you do want to create a new file. Again, I know this isn't definitive. It is to your judgment, but more times than not, just create a new file for each class you create. Is the policy I'm gonna recommend. But again, you guys are designers, you guys are the coders. Ultimately, you're responsible for your code and your code organization. Just make sure you do it sensibly, and that's all we can ask here. Okay.
All right, I just had a quick question because when me and Adam did it yesterday, we created one class that kind of used to store everything else, and that because it had to import 2 different classes, it would create a circular import if we didn't put them together. Is that just our kind of bad design, or is there like I'm just kind of curious.
Yes, you should never have a circular import. Again, I don't know your specific case, but yeah, circular imports definitely point to poor design or incorrect design. Yeah, because again, a circular import, just to describe that more if you're confused by that terminology, is the idea of hypothetically, let's say my staff class imported student because it needed student, and then my student class imported staff. Well, that's not going to work because again, it's an infinite loop if you can imagine it that way, where students saying, hey, for me to be defined, I need a definition for staff. And then staff is saying, okay, well, for me to be defined, I need a definition from the student. That's just going to be, again, recursive or infinite loop or circular dependency, however you want to phrase it. So yeah, that does point to some design issues. Again, the more complicated applications get, you might get into like cases where you might seemingly need circular dependencies, but there are ways around it. So I know that doesn't really give you a good answer right now, but again, there's always a way to avoid it, either by changing your structure or kind of doing some of the more advanced tricks to kind of getting it to work. But yeah, generally speaking, you should not be running into circular dependencies if you are rethink about your design, is what I would say. But good question to ask, absolutely. I know some other students ran into that also. Okay, so I think this completes both release 1 and 0. I probably should have had an incremental commit for release 0, but I'm just going to do a git add git commits, and let's just have a save point in case, we break something or it's going to come back to our release point. So release 0 and 1, combine there. All right, so I moved my files into my classes folder. My runner still works, so that looks good. Now, probably the most challenging part is loading data. So to load data, we need to read our CSV files. And that's something that Tom went over yesterday. We have this data, we want to read it in and then store it within our application so that we can manipulate it or just display it, whatever we want to do. So let's look at loading data. Next thing we want to do is load our data from CSV files using Python CSV module. If you haven't done so already, read over the docs. We're going to make a design choice and say that our student class will be in charge of talking to our student database. All right, this is something I want to highlight. I know some students will definitely question this and maybe did it a different way. Totally fine if you approach this a different way. Again, I'll say it again, you guys are designers, just make sure if you take a different approach, be able to back up or justify taking a different approach. And I would say this is definitely not necessarily the way I would do it, but since they're suggesting it, that's the way I'm going to go with it. So we're going to create a class method. So it says in our student class, we're going to create a class method. And we haven't talked about this too much. We've probably name dropped a couple times. When you use an @ symbol in Python and give it a name, this is something called a decorator. So I'm going to do class method. This decorator basically is going to apply to whatever is beneath it. So if I add a function here, def load all students, this decorator is basically like modifying how this function behaves, in that it's not going to be an instance attribute, it's going to be a class method. Okay, so load all students, and now obviously we want to load our students. So let's go through the business of reading a CSV file. I think I need to import CSV. And then let's get to it. So there's some coding help here. How to get your relative path. You need to import OS path, use apps path. All right, it's going to kind of take this code, make sure we understand it. Again, it's just find the relative path according to the file that's executing, and then it's going to create a absolute path from a relative path, it looks like. Or sorry, absolute path, and then joining my. All right, so my path is your base, and then this is your relative path. So you're making an absolute path that way. And then again, this is that syntax. Looks kind of funny, but basically you're opening a file and giving it an alias. So the alias for whatever file is open, that file object, we're calling it CSV file. So basically, it's like creating a variable that's holding on to this file object, just different syntax for whatever reason Python wants. All right, so I'm going to copy this good stuff, drop it in here, import statement. Doesn't need to be here. I'm just going to put it at the top. I think that's convention. And then let's see. All right. So OS, I need to import OS, which I did that. This, again, you shouldn't have had to modify this. It's just giving you a file path you can open. And I'm going to do with open path. That should be our file. I'm going to call this file. Makes more sense to me. Open file as a CSV file. Again, just a variable we're creating, and then we're going to read that CSV file. So I'm going to use dictionary reader because I think that is kind of easier approach here, but you don't have to use dictionary reader. So let's say dict reader equals CSV, dict reader, and then you got passed in the CSV file. By default, the mode for this is going to be read, so I don't need to specify the mode, but that never hurts to be more explicit. You're never gonna, again, having more information is definitely better than having too little information for someone reading your code. So I'm going to do mode equals R, which means I only want to read it. I don't want to accidentally write to it or append to it. So this is going to prevent me from writing out to this file via dict reader. So we get dictionary reader, and then we want to go through for row in dict reader. I think that's our syntax. Let's do something with it. So let's print out our rows for our dictionary. So row dictionary, name our variables appropriately. And let's just print it out. So load all students should be called from school. So I'm going to go to my school file. This is where I need to call school and then load all students. But since we're calling the school class, we need to import that because this module has no magic way of knowing what we're talking about. So we do from school, from classes, that school, because we want to be relative to a runner file. So a runner file is sitting outside this classes folder. And since that's going to be our main point of execution, we are making our imports relative to that. Again, it is wonky. I'm not going to say that it makes total sense to me either, but.
Encore.
Yep,
So how
Jason.
does it know what's so how does it know that the runner file actually, yeah, how does it know that the runner file is like in the root directory, I guess? Or how does it know where the root directory is?
It doesn't know. We know as developers. Like I know that my runner file is outside my classes. So basically I'm going to be running Python runner.py. So relative to runner relative to the runner file, I know that classes is a module I need to go into to extract my other modules. So it's just like I'm writing these imports relative to the runner file. And that's something that I know. My application is not making any decisions. It's kind of just.
So it's just based off of which file you actually run.
Yep.
Okay, gotcha.
Absolutely. Yep. Again, it is confusing. I wish it was better, but it's just the way it is, I guess. All right, so we're calling school loadout students.
So is that why you're importing from the school file
Yep.
rather than the student file?
No, that is a mistake. Sorry.
Oh,
If I did this actually, and I remember I saw someone doing this also. This is a typo. This will give you a circular import because what you're
Right, yeah,
exactly
that's
saying
what I
here.
thought. Okay.
Yeah. Sorry, that was my bad. Thank you for catching that. This would be an example of a circular import where we're saying to define the school module, we need to import the school module. So it's like, hey, for me to define myself, I need to define myself. Like that I get that wouldn't make sense. So yeah, this was intended to be students. I think I was typing and talking, which always gets me in trouble, but this should be student also. So yeah, we want to import the student class. It's down here, this will be student also. I don't know why I was writing school. Yeah, so we're importing students, and then this method, this class method load all students is a class method on student. So just want to make sure we understand what class methods are. Class methods are methods that don't depend on the existence of an instance for that class. What I mean by that is a mouthful to say, I don't need a student to exist for me to actually run this method. This method has nothing to do with an individual student. This method does, the way we've kind of, I guess, formulated it, it is related to students tangentially, as in we're reading in data and creating student objects. But again, no single student is responsible or needs to exist for me to do this operation, right? This is kind of an operation independent of the existence of any students. In fact, we're using this to create students for us. So again, hopefully I wired this up correctly, calling this method load all students, and we're just printing out the dictionary. So let's actually see what this outputs. Always good to incrementally test your application rather than do it all at the end. So clear, and I want to do Python runner, and we get an error. I think I need the mode up here. So always get to read error messages, right? I want you guys to get in the habit of this. I will say again, this isn't targeted to anyone, but definitely seeing some students kind of see an error message and kind of panic and just say, hey, I need help from a TA. Again, remember the 3 before me rule. Try to solve it yourself as in read the error message and actually see what's going on. And that should point you to, what is the problem. So here it says mode is an invalid keyword for this function. Again, these error messages aren't always the cleanest to read or the easiest to read, but again, they're going to tell you a line. So looking at here, it's pointing me to runner line 4, school line 6. This is my code. Notice that this dives into code that is not mine. So csv.py is what we're importing. That's not code I wrote. So I just want to stick to my code. So it looks like line 17 of student pi is what I need to investigate. So we can go down here and it says, all right, mode is not a parameter for dict reader. And that is, okay, that was an accidental mistake, but we make mistakes. I meant to put mode on the open. When we open it, that's when we specify the mode. Okay, so hopefully that clears it up. All right, there we go. So notice we get a nice, a dictionary for each row. We get Lisa, Jesse, Slater, Kim, Dave, Doug. I think I want to change these to the actual Stay Well students later, so maybe update that. But we get screen printed out like before, but this is our data. And going off of, working with some other students yesterday, how do you want to store this data? Well, what if we create a list and say students or all students and initialize that to empty list? What if we just store these dictionaries, right? Not sure what I did there. Let's do all students, and then we're going to append that dictionary because that dictionary contains all the data we want. Cool, append that, and then finally, after we do that for each row, we're going to return all students. All right, so we're returning a list. That list is going to have each entry is going to be a dictionary. Return all students, and that's going to be stored here. This is where I will say this will work for me. I'm grabbing the data and I have access to all the data I want. So for example, if I go to my runner file, let's get all students. I'm going to delete this stuff. Let's do all students equals, actually I didn't even do that. I have access to it through school. So school dot students. And then, let's say I want to print out for students info and students if students info dot or square brackets name equals Lisa. Let's do Jesse actually. Jesse print student info. I want to see the GPA. So her GPA was a 4.0. So print student info GPA. All right, so this is a dictionary. We're just extracting name and checking it and then printing out the GPA. So if I did this correctly, this should print out 4.0. Let's verify that. And if I did not, that is my bad. All right, so clear. Let's do Python runner pi. Notice we get 4.0. That is Jesse's GPA. All right, this works. It looks like I'm extracting data correctly. I've stored it. Can anyone maybe comment on what maybe I should be doing here though? Any thoughts?
You should use this data to create object.
Yes, thank you, Yaping. Absolutely. So yes, we read in this data, but I question myself is why do we have the student class if we're not using it? Right? We create the student class, it can keep track of that data, but here we simply read in our CSV file and then they're storing that as dictionaries. Again, this can work for your needs, but it's not the correct OOP the way to do this. So your data is just data in your CSV file. You want to take that data and create objects from it. So instead of just storing the dictionary, I want to create actual student objects so I could have a better representation of students in my application. Right? So luckily, since we know that trick, I can simply create a new student instance. So let's do it line by line. I'll do, let's call it students equals students class. And then I'm going to do that double star, which is going to be my spread operator. And then row dictionary is going to be broken apart and be fed in as quargs to my init method. Right? So again, this makes it kind of handy if you use dictionary reader and use quargs. All I had to do here is append student. So the extra step we went here, and you might say it seems unnecessary, but no. OOP, you want to work with objects. You don't want to just have raw data kind of floating around your application. So I create a new student object, and then I append that student here. And so now, if I run my application again, notice I had dictionaries before. Let me run Python runner. Students, not, all right, again, error messages. Yeah, so it looks like I need to change my runner file here because I was using subscripts. So instead of doing this, simply I need to change this to dot name. And I need to change this to dot GPA. Because I'm using classes instead of using a dictionary. So I think that should clean up for me. There we go. So so get 4.0, where is this coming from? Sorry, I forgot what I statement. Oh, yes, thank you. I left that in this print statement right here. So that's why we're still seeing a dictionary there. My bad. Let's actually do this in a runner file. So let's actually print out each student info. Save, clear, run that. All right, notice we get these classes. We get a 4.0 sandwich between here because the second student happens to be Jesse. but we're getting actual objects now instead of just having dictionaries. And this is, again, this is the OOP principle of creating objects and using them within your application. Question for anyone in the audience. This looks kind of weird. How do I actually see something more useful when I print something out? So anyone remember?
String,
Find a dunder
double
method.
under string.
Yeah, I think a couple people said it. Yeah, want to add a dunder method. So just get in the habit of always creating a string method. When we get into Django, this is going to be more relevant because you're going to be having more front end items that depend on your string method. Otherwise, your user is actually going to see this like in a drop down. They'll see this, and that's not what users should be seeing. They should be seeing human readable items. So we'll do self, and then return students. Just put the name and ID of this.
So do we still want that under the class method?
Oh, nope. Sorry, I got lost track. That should be an instance method, not, it has nothing to do with the class method. Thank you for catching that. So self, student, I need to format this with an F string, and ID, self.id, or student ID, that's what we called it. All right, so and let's add in GPA since we bothered to add that in here. GPA is self.GPA. Okay, so that's, now that we have the str method, let me run this once more. There we go, much more informational on my command line here. So I have Lisa, ID 13345, GPA 37. Okay, that's the purpose of the str method. All right, cool. So we've done that for our students. I'm gonna kind of expedite the part for the staff because we are running a bit long here. I'm gonna copy this. I'm going to put it in my staff class, and there we go. Only thing that needs to change here is instead of students, I need staff. Everything else, I need to get some imports here, it looks like. So I need CSV and OS imported here also. There we go. This should be staff. Otherwise, everything else looks like it can stay the same. Probably should rename my variables. It should be student, it should be staff, but it would still work because it's just a variable name. If you want to be appropriate, so that should be staff. This should be staff also. Still would work, but we're not bad coders, are we? All staff, all staff, all staff, and then finally my school class. We're gonna do the same thing we were doing before. So copy this from import staff. All right, any questions as I'm kind of expediting the staff portion? Because again, it's the same idea as with student, and then hopefully this is raising some yellow flags in the back of your mind that we're going to tackle soon. So load all staff.
I'm having a heck of a time with like where you have from classes.staff import staff. For me, like import students just grayed out, and it's like one file just will not see the class in another file. Do you know why that might be happening?
I do not. If VS Code is graying it out, that just means it's not being used. So if I wasn't using student in here, so let's say I was, had this in here, it grays out student, which means I'm not using it in this file. If that's the gray out you're seeing. If you're seeing something else, yeah, I might need to go one-on-one with you. But yeah, again, VS Code is just kind of identifying what is being used. You could do that with parameters also. So if I didn't use name here, if I just said blah, notice it grays out name. It's just kind of hinting at the developer like, hey, maybe you don't need this parameter to exist, or maybe you missed, you forgot to use it. Okay, so we have student, staff coming from the respective modules. Let's quickly give this a run, make sure that we can see staff info, and then we'll do one more thing after this and we'll wrap up quickly. So there should be school.staff. Staff. I'm not going to print out anything specialized, print out staff info. And we need to add our str method. So I'm going to borrow that from here, go to staff and drop that here. So instance method. Why are you yelling at me? Tabbing. And then staff. Let's print out the name. And ID. Employee. Okay, so let's run our runner file, make sure our staff load is just the same. So let's take a peek at our staff data, make sure we know what to expect. So we have Culpepper, Dewey, Mertz, XX, I guess his name, not sure. It seems like it's a typo. Okay, so that's what we should expect. Let's actually verify that by running a runner file. So I'm going to clear Python runner. All right, there we go. That looks like we're loading in data correctly. So again, the same principles that we did with our students, reading in our student data, again, creating an object, we're doing it with the staff. Does anyone have any concerns with the code I wrote? Anything that maybe I can improve upon?
I just had a question actually. So if you go back to the runner file and you print out, just directly print in parentheses like school.staff or school.students, you print out objects. Is that correct? So if without the for loop.
Yeah. Yeah, so this is not going to print out the details. So run this. You get this, and the reason is because it's nested within a data structure. So it doesn't actually go into that data structure and call str in each method. I think people were saying the repra might get around this. Let's actually try it. Repra and repra. So again, this is another dunder method that's very similar to str, so much so that I can't fully tell you a difference at this point without reading it myself. But let's run this. Yeah, okay, so it looks like repra is smart enough to do that for us. So that might be a reason to use repra over str. Again, they both essentially do the same thing. If you don't have an str method, it will fall back on repra if you define a repra method. But it looks like that is better. So yeah, that's a rep for repra if you want to start using that. Looks like that was solid. But yeah, good question. Thanks for asking that. Discover that repra is a little better there. Kana, since we're chatting actually, did you happen to do this a different way? And if so, could you maybe talk about why you did it a different way?
Well, we did it a different way a little bit yesterday, but I switched it back to this way
Gotcha,
for my
okay.
final.
Well, I was hoping, yeah, again, so totally fine if any of you guys did it a different way. So someone brought this up and I totally agree. You could totally have, if you decided to have a method saying load all students here. I think some students thought about doing this or maybe even did it. This I could justify this also. And in fact, I likely if I was doing this on my own, would probably do it this way. So this load all staff method would be exactly the same as this method that I created here, but it would not be a class method. The reason being is because you can you're instantiating a school and then having that school load all students effectively for you, right? Because we're storing the data on the school as instance members. So this would be an instance method if you added it to your school class, but if you added it to your student class, it needs to be a class method. Because again, it does not rely on an individual student, but these students rely on a school to exist, right? Because we're storing students within a school. So again, this is totally fine if you do this way, great. I'm glad you kind of critically thought and like, hey, this makes more sense to me, I'm gonna do it this way. Total liberty to go to do it that way. All right, does anyone see anything else that maybe I can improve on here?
You could extract, since the student and staff code are exactly the same, you could extract that back into person.
Yep. Who said that? Was that James?
Sir.
Yep. James was totally correct. If you notice, I totally just copy and pasted my load all students logic, put it in staff, and renamed a couple things. I renamed my data file and a couple of variables, right? That's the only thing I needed to change. But for all purposes, all intents and purposes, this is exactly the same logic, and this is violating the dry principle, right? My code is becoming wet, becoming soggy with extra code that I don't need. So this is a great opportunity to use our base class, because we do have a base class, to kind of centralize that. So I'm going to do this with the class method still, class method. I'm going to say load. Guillermo, you have a question?
I actually just had I had a question about the def string method. Are we always going to have one of those methods in our base class, because we're always going to need to print stuff out that we need to see? Is that a good approach to, I guess, creating a base class that you're always mostly going to have this def str method?
Yes, I would say if you're forming good habits, just always take the extra 10 seconds to create an str method. Even if you're not going to use it, just have it there. Because again, when we get to Django, you're gonna always want to have it just for UI purposes. So yeah, I would just say, just do it. Just think of
Okay,
it as
that's perfect. Thank you.
you create an init method, just create a SCR method right there before you forget. I forget.
That's exactly what I was thinking.
Yep. Okay, cool. So loadout people is gonna do pretty much the same thing that I was doing before. So let me copy that code, paste it down again. The idea here is we're centralizing similar logic. It's the same idea as where we centralize similar data. Like this data was shared, so we centralize it. We're doing the same with our logic here. So I'm going to do this a bit quickly because again, I'm not adding anything really too new, but there's some things we're going to need to talk about. So we'll talk about that at the appropriate time. But I need to import some stuff here. CSV OS. Okay, as we talked about, what is different between student and staff when I'm loading in? Anyone?
Think in the CSV file, they're named, some of the columns are named differently.
That is true. Yes, their columns are different. We have employee ID for one, we have student ID for another. So those matter, but that's me kind of covered here. Like the dictionary reader doesn't care what those are. But when we're reading in the data, like the data file matters, right? If it's a student, we need to read the student's file. If it's staff, we need to read staff. So in this case, I'm going to add a parameter here and say file name. All right, so file name is what we're going to pass in. So this will become file name. And then we're going to make this generic. So we call this person. And then this is where, sorry, this should be class. Not sure that. All right. Let's talk about that in a moment. Let's actually go back to our students. So assuming we have that method working, all we need to do here is call that function. So we're going to call super load all people, and you got to pass it a file name. So that file name was what I checked it out. So again, this is dependent on if we're working with students or staff, but otherwise all the other logic is shared. So that's in my base class. I'm going to copy this, and I guess I can get rid of my imports. Don't need you guys anymore. Staff, same thing. Go away. Thank you. And then this will be same thing, except this needs staff. Now there's one more thing that we need to change in our base class. And this is kind of a little more advanced. I covered this during a stand down yesterday, I think, but we're going to reiterate it today. I have this base class, but I need to create instances of a student or a staff. I don't want to create just people, just a person instance, right? Because that is not relevant to my school. We don't just have persons or people. We have students or staff. So down here, for my student example, I had to create a student, but this is generic. So I might use this for staff. So I can't hard code student down here for two reasons. One, my person class has no knowledge of student, right? Person is a base class. I cannot, all right, cannot and should not import from students classes dot student. Why should I not do this? Can someone tell me?
Students is dependent upon the person class, and you can't have backwards dependency. You can't have the arrows go in both directions on our little arrow chart. You can only have the arrow going one
Yep,
way.
Michael mentioned a couple things there. One, student is inheriting from person, so person should not, person's a generic item. It should not know anything more specialized like student. Also, this gets back to circular dependencies. Student depends on person. If we're trying to do something like, all right, do some student stuff here, that's a circular dependency, right? Because we import one and the other and the other and the other. I don't know if I butchered that. But yeah, this is not what you want to do. This is, again, kind of sneaky, but this is what you guys should understand about class methods. Let me back up one step. Instance methods. Again, instance methods taken as self. That self refers to a particular instance calling that method, right? So that's what self is. For class methods, we have class. So this is actually referring to this class, the name of the actual class. It's not a particular instance. We don't need to create a student to call this method, but we do need a class for this class method to exist. So this is what we can leverage. The CLS refers to students if student is the actual one calling load all people. And this is some Python magic. So that's what class is pointing to. Class is a reference to the actual class, the type of class it's calling this. So instead of writing student here, I can just write CLS. So CLS is just a reference to that class. And now I create a person. And that's what I'm going to append to here. This should read all people. Let's call people. We have a plural word for it. People. I don't like that. Let's have that all, just so I know it's aggregating something. All people. All people. Okay, so again, this is making it generic so that both staff and students can call this function, and CLS will appropriately know to use staff or student based on who's calling down to load all people. All right, so we create a person, push it in here, and pass back. This is super generic. It's so generic, in fact, that I don't want to change anything for staff. Staff is doing the same thing now as student. The only difference is the file we are telling it to open. Because obviously the base class can't magically know that. I think James was saying he made it dynamic so that his maybe generic method extracted the class name. And since our data files match our class names with lowercase, I think he used the class name and used that for his file name here instead of having that the parameter, if that makes sense. Like he just used class and realized if we're working with students, we need to open the student.csv file, which is kind of nifty. That's just assuming that your data files are named matching your class. But okay, so now this is super generic. I know someone had a question, but I'm just going to run this to make sure this works and then definitely get the questions. So Python runner, cool, still works. I didn't break anything by making a generic class. Again, this is the dry principle. We identified that something was super generic, and something was redundant, and we removed that redundancies by centralizing it so that our derived classes don't have to do that work separately. They are using the base class. So again, our derived classes, staff and student, are super simple. There's barely anything here. We just have extra data. And we have like a file name we need to specify and a different refer method, but yeah, nothing too exciting in these classes because the base class is doing most of the work because they could share that logic. Okay, that was a lot. Hopefully you guys were able to complete School Interface 1 on your own. If not, hopefully some of the work through that we did here kind of made sense and allows you to go back and put it. Was there a question out there? I heard someone speaking, I think. It's not, because my ears might be playing tricks on me. All right, so I think that accomplishes release 3. I think we combined 2 and 3. I guess I kind of did that, but yeah, we could print out student and staff, but not going to bother with that. So git add git commits completed release 1 and 2 and 3. All right, and then we do a git push origin, and then all right, I'm not going to bother with this. I have some issue with this. Yeah, git pull. Looks like someone updated that file. Must have been me because I updated that README. So git pull. So git pull basically adopts the changes from above. Looks like it merges. All right, I'm not going to deal with this because that's not interesting. But can I commit that? Cool. All right, I think it's because I edited my file. Remember, I added in that optional part right here. So my changes were not in line with what was clean on my request. Wait, that was School Interface 1. Hopefully you guys enjoyed it because there's 3 more iterations of it. So there's more to come with that. Any questions about School Interface 1? Okay, let me stop the recording then.